Okay. Okay, then let me start with the
In the previous lecture, we have discussed about the congestion. We also have discussed why does it occur, how does it impact the communication, and also how to take care of the congestion. Or in short discussion, we have seen what we are supposed to do or what the network is supposed to do when there is a congestion in the network. As we have also discussed, the congestion is taken care of, maybe taken care of, or it is taken care of in two different layers. One is in network layer, and second is in transport layer. Transport layer. In the network layer, basically, there is one special kind of packet in the network layer, which is called choke packets. Choke packets are used, KE. Choke packets are used by the network routers to inform the neighbors about the occurrence of congestion and thereby requesting them to slow down the transmission in the network. In the transport layer, not all transport layer protocols like UDP, it does not take care of congestion. However, the connection-oriented and reliable protocols like TCP take care of congestion. In this session, we will discuss how congestion is taken care or how congestion is managed in TCP protocol. Also, if you remember, we have seen that when any connection is established between two devices, then the first segment or first message transferred from the source, which is the requester of data, to the destination, which is actually the supplier of the data, it first transmits the sync packet. In response to the sync packet, the receiver or the supplier of data, it sends one acknowledgement packet. In the acknowledgement packet, he sends one data which is called the window size, WND. This window size defines how many bits can be received by the destination. This window size is very important to control or manage the congestion. All these things we have discussed in our earlier sessions. Taking into consideration the concept of window or the willingness of the destination to receive a certain number of bytes continuously, we will proceed further to discuss the TCP congestion control mechanism, right? And in such type of protocols, or specifically in TCP, it uses a congestion window. This is denoted by CWND, congestion window. And this window is maintained by the sender. And window is nothing but certain set of sequence numbers which can be communicated via the transmission media without interruption. This window may be bigger than this, but this portion is called the window. And all the sequence numbers within this may be communicated without interruption, like sequence number 6, sequence number 7, sequence number 8, that way up till 10. all the sequence number could be communicated. That's why this is called a window. And similar window is maintained in the sender side. The sender maintains one window which is called congestion window, denoted by CWND. And this congestion window indicates the amount of data that can or that the sender is planned to transmit without interruption. Please keep it in mind here. There are two windows. One is this WND window, which is communicated from the receiver, from the destination to the source, right? And congestion window, which is being set up by the sender to the destination, right? Sender to the receiver. So here, the concept of, we will briefly discuss about this congestion window, and also we will see how this congestion window is used to maintain the or manage the congestion in the network. So congestion window is maintained for each TCP session and represents the maximum amount of data that can be sent into the network without being acknowledged. Whatever I have said here, exactly same thing is replicated. Initially, it sets, that is, the congestion window is set to maximum segment size, MSS. It is very, very important. And periodically, after particular period of time or after certain transmission, this congestion window is either incremented or decremented. This is called adjustment of the congestion window. And there are different variations of TCP protocol which defines the congestion window, or which defines the process of changing the congestion window in different way. So we will see few of them and also we will see how this congestion is managed with the help of the congestion window, and subsequently how this congestion window is adjusted over time. So here, very important term is maximum segment size. Now let us see what is this maximum segment size and how it is computed. If we have a look at this diagram, this is the diagram of different segments. As you understand that every layer, say this is the TCP protocol stack, and each of the layer, starting from application layer, transport layer, network layer, data link layer, and physical layer, all these layers add some header to the data. If this is the data, then application layer will add one application layer header, then transport layer will add its transport layer header, network will add its network layer header, and so on, so forth, right? And each of this part, for every layer, for say transport layer, the part up to the application layer header is considered as a data or payload. Above this data or payload, it will add its own header. This is transport layer header. Similarly, when it will come to the network layer, this payload for the network layer, it includes the transport layer header, application layer header, and actual data. This becomes the payload, and the network layer will have its own header part in the network layer header part above this payload, right? So here, what we are telling that this is the payload. This payload indicates that this is the header which is added by the TCP layer or TCP protocol, transmission control protocol. And this payload part includes the application layer header plus the data. Altogether, it is called a payload. And this segment, excluding the TCP header, is called TCP MSS, maximum segment size, right? MSS stands for maximum segment size. This maximum segment size is determined by means of bytes. It considered as a byte, normally 1024 or here 1460 bytes. That depends, and mostly it is 1024, 1024 or 1460. These many bytes, either this one or this one. And this protocol or this example assumes that it is 1460, and all together it should be 1460 plus 40 plus 14. That is all together, it is 1514. Total size of the packet will be 1514 plus these 4 bytes. That you will understand when we will discuss the physical layer or data link layer. If you have studied, you might have understand that. But here in this discussion, the important thing is the size of MSS. The size of MSS is 1460 bytes plus the TCP header. TCP header is 20 bytes. So that means this part will have 1480 bytes. And when we consider, if I say this is the client, this is the server, and it sends the segment sync packet, and it will reply this, and the number of bytes which is indicated by the receiver with the help of this window, and also in the receiver side it is denoted, the variable which is used for congestion window, CWND. All these two indicates about MSS. If it is says 2, it means 2 MSS, and 2 MSS equals to 2 multiplied by 1460 bytes, and that becomes the segment, right? So based on that, with this concept of the segment used by TCP layer, TCP protocol, basically transmission control protocol, we will see how this congestion is managed. Okay, so how it is being accomplished? Let us say the sender first, what the sender will do. Okay, what the sender will do. First, suppose suppose that these are two nodes. They are trying to communicate, and we assume that here the connection establishment phase is over. This here till this one, connection establishment. This is very important actually. Once the connection establishment phase is completed, this is connection establishment phase. this connection establishment phase is completed. By the time this sender or the cell, this is a client and this is a server. This is a server. Both the client and server, they are now ready with here. Client will receive the RWND or say WND, which will have some number of bytes. Okay, number of bytes. Say 3000 number of bytes. 3000 number of bytes. And similarly, based on this, it will understand that this is the number of bytes maximum that can be communicated. And that the same number of bytes will be converted into MSS. As we have seen that 10, what is the size of that MSS? What we have taken, the size of MSS as? This is 1460, right? So 1460, let me redo it again. White screen, right? 1460. The MSS is 1460. If I multiply it by 2, that means 0 to 9, 2920, right? 2920. Suppose that this one is 2920, not 3000. This is say 2920, right? This is 2920. And it will set the C, based on that, it will set CWND. CWND initially set to 1 MSS. 1 MSS is equals to 1460, right? And it will set one buffer like this, and these buffers will have the sequence numbers. Let us assume that the sequence numbers are starting from 0, 1, 2, 3, again 0, 1, 2, 3, or somewhat like that. It is not exactly the same as the flow control mechanism that we have discussed in the earlier session. However, it will maintain one disk and it will set one transition window, CWND. Since CWND, I'm assuming that one sequence number from the data set, one sequence number is, if it is 0, that means here it has 1460 bytes, 1460 bytes. And after that, again, it will start it will start from 1461. Then again, it will go on. And from here to here, it is total 1460 bytes. And what it will do, it will send immediately. Now, this is the setup. This is called congestion window. One pointer will be located here. It indicates that it is pointing to the first window. And then it will send the first segment. Segment 0 is communicated. Then definitely the server will reply. It will send the acknowledgement in response to segment 0 and will request the send me segment 1. Now here, let us say at this point, the client has received this A1, right? That is acknowledgement for the first segment. Then it has to recreate the window. It is 0. This 0 acknowledgement for 0 is already received. So now this is 1, this is 2, this is 3, again this is 0, this is 1, this is 2. That way it goes on. Now what it will do, it will increment. It will, first of all, it will move the window towards right and it will include 1. And since one segment is acknowledged, that's why it will include one more segment, right? And then it will start transmitting segment number 1, and immediately it will start transmitting segment 2. Let us suppose that this is not, receiver window is not only 2920, maybe it is more than that, which is equals to, say, we can include up to 8 segments, up to 8 segments, right? Up to 8 segments. And what it will do, or what it will do here, this S1 will be acknowledged, this S2 will also be acknowledged. At this point, the window size will include 0, 1, 2, 3, 0, 1, 2, 3. Since 2, we have 2, 1, 2 is over, then starting from 3, it will include 1, 2, 3, 4. 1, 2, 3, 4. What does this mean? After reception of every acknowledgement, it will increase the size of the congestion window by 1 more unit. When 1 was received, the size was 2. When 2 acknowledgement was received, the size is 4. When 3 acknowledgement is received, the size is 8. That way it will go on, right? So this is the procedure, and this procedure will not continue indefinitely. And for that, the TCP also maintains another variable. These are called variable. Congestion window size is one variable. There is another variable which is called threshold, denoted by SS threshold. Threshold. This is also, it indicates number of segments. While incrementing this window in this direction, it will look for this value. When it reaches this value, modes of transmission or modes of incrementing the window is changed, right? That's what we will see in our next part. Let me have a look in detail, right? In detail. So this is one such window that we are taking into consideration. This is called TCP congestion control mechanism, right? This is called the TCP congestion control mechanism, or also known as the protocol used by TCP to handle or manage congestion. Right? This is called a method which is used by the TCP to handle congestion. What it does? In the sender side, it maintains one, as I have told you, it maintains one window. This window comprises of some sequence number 0, 1, 2, 3, 4, 5, 6, 7, that way. It can go to some maximum range, again it will repeat. And initially the congestion window CWMD is equals to 1. In that case, it will have the congestion window size that is indicating only to one segment. And after that, it will send the it will send the data packet, or it will send the segment. Once the segment is received, this is the client and this is the server, client and server. It sends the first segment and the receiver will send the acknowledgement. Then the acknowledgement, upon reception of this acknowledgement, this window will be increased by one segment, 0, 1, 2, 3, 4, and it will be 2. Again, these two segments, when these two segments are acknowledged by the receiver, it will receive two segments, acknowledgement segments. At this point, it will be, when both the acknowledgement will be received, what it will do, the client will increment the window. Now 0, 1, 2, 3, 4, 5, 6, 7, 0 and 1, it is already received. So 1, 2, 3, 4, it will go up to 3, that's why 2 more, it will be 3, 4, 5, 6, 3, 4, 5, 6 up to this, right? So this way it will go on. Again, these 3 segments, 3, 4, 5, 6, and similarly 3, 4, 5, 6 will be received. Once 3, 4, 5, 6 is received, then this window will be 0, 1, 2, 3, 4, 5, 6, 7, maybe let us say continuously 8, 9, 10, 11, 12. So up to 6 it is received, and up starting from 7, it will have 8 segments now. 4, earlier it was 4, 1, 2, 3, 4, 5, 6, 7 and 8, 13 and 14. So this way, this window will keep on increasing, right? This window will be incremented that way. Once the acknowledgement received, it will expand the window. And this one can be represented with the help of some graphs. One segment is communicated. Then once it is acknowledged, then this size of this is called size of the congestion window. This window size is nothing but the congestion window size, right? Congestion window size. This diagram represents how the size of congestion window is increased in TCP congestion control mechanism, right? First, it will take one segment. This is from here to here. This is one segment. Once acknowledgement is received, it will be increased by 2 segments. This one is received, it is increased by 2 more segments like this. This part is called the slow start phase of the congestion control mechanism. Now here, also we have said that there is one more variable, threshold. There is one more variable maintained by the congestion control mechanism, which is known as threshold. This is set to some arbitrary number which indicates the maximum segment size. For example, let us say it is 8. It is also known as SS threshold, right? SS. SS stands for slow start threshold. Initially, the congestion control mechanism of TCP starts with a slow start phase. In the slow start phase, the size of congestion window is incremented by 1 for every successful reception of the acknowledgement. And also it sets one threshold value. The slow start phase continues till the threshold value reaches. When the threshold value reaches, it changes the mode of transmission, or it changes the mode of increasing the congestion window size. What it does, suppose with the value of SS threshold 8, we have entered in the congestion avoidance. This part is called congestion avoidance phase. And here what it does, instead of, let me do it once again. Discard this, okay. Let us see how it will work when okay, so this is the scenario. We have seen how the slow start phase works. It starts with one segment. It increments by one segment every time one acknowledgement is received. And then it goes up to a threshold value. Threshold value here is assumed as 8. Okay, so what it does, after that, after reaching the threshold value, suppose at this point of time, the window looks like there are 8 segments in the window. 8 segments, because at this point the window congestion window size is, let us say, 8, 0, 1, 2, 3, 4, 5, 6, 7, then 8, 9, then so on and so forth. Now this is the congestion window. Do you remember why it is? This is because we have just finished the slow start phase, and in this phase the congestion window size becomes 8. Once it becomes 8, and if we follow the slow start phase after receiving the acknowledgement of all the packets, all the segments, it should be increment to twice of this 8. That means it should be 16. Since we reach the threshold, that's why it will not increase, the congestion window will not be increased to 16 rather than that, because up to 7 we have received all the congestions, all the acknowledgements. So this is the congestion window. It will start 0, 1. Already it is up to 7 it is received. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That way 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be, this congestion window size will be 9. It implies that previously, for every acknowledgement received, the size of congestion window was increased by 1. For every acknowledgement, it was received by 1. But in this case, when group of, means all the segments within the congestion window, acknowledgement for all the segments within the window is received, then it is increased by 1. So this phase is called congestion avoidance phase, and in that phase, the congestion window is incremented by 1, incremented by 1 for entire congestion window acknowledgement, right? So this way, this process continues. Now now we have seen 2 different phases. One is called slow start phase, another is called congestion avoidance phase. And congestion avoidance phase starts when we reach a threshold. And after that, after starting the congestion avoidance, this congestion avoidance phase continues until some congestion occurs. Now, at this point, we are showing something. This is very important. What happens here? When a sender sends the data, or when a client and server, they exchange data, it sends the data, and it is supposed to get the acknowledgement. Now, if we do not get the acknowledgement, it may be considered by the client as an occurrence of congestion. This is automatic detection of congestion. So when a sender receives, this type of, does not receive this type of acknowledgement, this can be considered as a congestion. If you remember, when a source transmits a packet to the destination, it starts one timer which is called RTT, retransmission timer. And when this timer expires, then the client assumes that, or the sender assumes that there is a congestion, there is a loss of packet, and it retransmits the packet. This is one region or one method of knowing about the congestion. The second method or second way of knowing about the congestion is, suppose that the sender is sending the packet to the destination. The receiver has received this packet or received this segment. However, the acknowledgement is lost. Again retransmits, again acknowledgement lost, again retransmit, again acknowledgement is lost. In that case, what it will do, the receiver, since receiver will inform the source that don't resend this segment, say segment n, rather than that you send segment number n plus 1. So this is called the acknowledgement. This is one acknowledgement for retransmission, or acknowledgement, this is not for acknowledgement for retransmission. This is called acknowledgement, which is necessary for transmitting the next segment. And this is called actually the acknowledgement or duplicate acknowledgement, right? Duplicate acknowledgement. Why it is called duplicate acknowledgement? Because repeatedly the receiver receiving same segment once, twice, and thrice. 3 times it has received the same segment. In that case, the receiver will inform the source that do not send the same segment number of times. This is considered as sender receives 3 duplicate acknowledgements. Means the sender will receive all the acknowledgements, send me to, send me to, send me to. Okay, if it gets this kind of 3 similar segments, it is assumed that there is a congestion in the network. So what it does, reception of such 3 type of different 3 acknowledgements, 3 duplicate acknowledgements, it will drop down. This is called dropping of congestion window. It will drop the congestion window to half of the current window. If it is now, it is, how much is this? Here it is 9 by 2, which is approximately 4, and it will lower down the congestion to 8, 9, 10, 11. It drops down the congestion window. It also sets the SS threshold, right? Congestion window will be 4. It will also sense the SS threshold, which was earlier 8, and it will divide it by the current window. This is current window, current congestion window, which is 9 divided by 2, which is again 4, right? And it will start again, it will again start the congestion avoidance phase, right? So this is another phase of congestion control. The first phase is slow start, second one is congestion avoidance. After that, this is called congestion detection phase, right? In the congestion detection phase, what it does, first of all, it will change the 2 things. One is the congestion window and another is the SS threshold. When the congestion is detected by means of 3 acknowledgements, then the congestion window is dropped down to current congestion window divided by 2. SS threshold is also same as this current congestion window divided by 2, in this case, which is 4 and 4. And otherwise, what happened here, sometimes the congestion is also detected by means of the timeout, right? Timeout. That is, the sender has communicated the segment, it has started the timer, and this segment is lost. That's why timer expires. If timer expires, then it will retransmit. So retransmission happens here, and it is assumed that this is retransmission is because of the segment is not received. So that's why it assumes, the client assumes that, the sender assumes that, or there is some congestion in the network. So it has to take care of the congestion. In that case, it will do the same thing. Same thing means it will change the congestion window, but this time the congestion window will be set to 1 MSS as it is done in the first case, and SS threshold will be equals to the size of the congestion window, 9 say divided by 2, which is equals to 4, and it will enter the slow start phase, right? So slow start phase, again the slow start phase will start, and again this is a threshold. After threshold, it will start the congestion avoidance. After that, if congestion detects, then it will drop based on the 2 factors. It will think about 2 factors. One is whether the congestion is detected due to 3 duplicate acknowledgements, or the congestion is detected through the RTT expiry. In both the cases, it will consider that there is a congestion in the network and it will react accordingly. In case the congestion is detected due to 3 acknowledgements, then it will drop the congestion window to half of the current congestion window. It will set the threshold to same value, and then it will start the congestion avoidance. If the congestion is detected as a method or as a timer expiry of the RTT timer, then it will drop down the congestion window to 1 MSS as the starting phase. Then it will enter the slow start phase. Again, this process repeats. Okay, let me tell once again the very clearly the same thing. What we are discussing is about how the congestion is controlled, how the congestion is managed in TCP, right? To maintain congestion in TCP, it uses primarily two variables. One is called congestion window. It represents number of segments can be transmitted at a time or without waiting for acknowledgement. Initially, it is set to 1 MSS. It also maintains one slow start threshold, which is equals to some random variable initially, let us say 8 MSS. And this diagram this graph represents the congestion window size in this side, and this side the time in number of segments transmitted, right? And it creates one congestion window. Initially, it is set to 1, let us say 0, 1, 2, that way it is set to 1. The first phase, the congestion control in TCP is handled in two different phases. One is called the slow start phase. Second one is called congestion avoidance phase. And third one is called congestion detection phase. In the slow start phase, for every acknowledgement received, the congestion window size is incremented by one segment, right? For example, here if 0 is acknowledged, then the congestion window will be 1 acknowledgement is received, so it will be 1 and 2. Right? When both these segments will be acknowledged, then the congestion window size will be 0, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, like this. 7, 8, and it will go on in this way. And how long it will continue? It will continue till the congestion window size will be equals to, will be less than or equals to SS threshold. Once the congestion window size is greater than or equal to SS threshold, it enters in the congestion avoidance phase. So what happens in the congestion avoidance phase? Let's check what happens in the congestion window or congestion avoidance phase. Here, in the congestion avoidance phase, let us suppose that at the time of reaching the SS threshold, at the time of reaching the SS threshold, this window looks like, right? This window looks like, this is, say SS threshold is, for time being, let us assume that SS threshold is equals to 4. That means it is 0, 1, 2, 3, 4, 5. So this is, if I assume that this is the congestion window, and congestion window at this point is equals to 4 plus 1, which is equals to 5, right? This is equals to 5. And now we reach the SS threshold. SS threshold is equals to 4. So what it will do, it will change the congestion window to, for all the acknowledgement, if it 4 acknowledgements are received, it will be increased by 1, right? So congestion will be now this, in the congestion, this is called congestion. Once this is SS threshold is received, it enters the congestion avoidance phase. In the congestion avoidance phase, for acknowledgement of entire congestion window, the CWND is increased by 1. So this is called congestion avoidance phase. And this phase continues till congestion is detected. If congestion does not detect, then it will continue for forever. Otherwise, if congestion is detected, then it changes the mode. What it does, the congestion is detected by 2 different methods. One is through 3 duplicate acknowledgement, and second one is by RTT transmission expiry, RTT expiry. So both the cases, it will adjust the current window, congestion window, CWND. In the first case, if it is because of 3 acknowledgements, then the congestion window is dropped to half of the current window, okay? Half of the current window, and whatever the current window, it is 5 by 2, it is equals to 2. It is equals to 2, right? It is equals to 2. It will drop down to half of the current congestion window, and SS threshold will also set to the same value, 2. Then it enters the congestion avoidance phase. Otherwise, if the congestion is detected by means of RTT expiry, then congestion window will be dropped down to 1. Then threshold will be dropped to current congestion window divided by 2, which in this case it is 2, and it will enter the slow start phase. Okay, hope you have understood the concept of congestion control mechanism in TCP.
Any query? Do you have any query? Okay, then quickly give your enrollment numbers to take the attendance.